Okay, hi everyone. I hope this video finds you well. So today we are going to talk about Java generics, and we are going to see what they are, and why do we use them, and how to use them. So before you start, create a new project in Eclipse called Sandbox 8, and keep this project in case you need it in the future. So Java generics. So generic programming is a style of programming in computer languages in which algorithms are written in terms of type to be specified later, that are then instantiated when needed for specific type provided as parameter. So when creating a container classes in statically type languages, it's inconvenient to write specific implementations for each data type contained, especially if the code for each data type is virtually identical. So let's say we are creating a class, or let's say a method that adds two integers. So you would do add, and this take int x and int y. So you're doing that for two integers. What if we want to have a function that exactly does the same thing, but instead of two integers, two doubles? So you would do exactly the same thing, right? Add, and you would give it double and double. If you want to do exactly the same thing for float and float, and so on. So basically you're creating identical codes. So you're copying and pasting and you do some changes, right? So generics allows you to abandon this bad habit of duplicating code. So you have already used them. So they are not actually foreigners. So you have used them before. You have already used generic classes. One big topic we had before is array lists. And in these array lists, you were using generics before. You use them in pretty much most of your projects. And array list is a common generic library, and we use the diamond operator. The diamond operator is basically the two angle brackets. The two angle brackets you can find in the keyboard. So inside those two angle brackets in this diamond operator, you can have what type of your array list elements would be. So in this case, I have my array list of animals. Now I can have dogs, pigs, lions, and all these animals in there, right? So generics basically are a facility of generic programming that were added to the Java programming language in 2004. Within its official version, the J2SE, the standard edition 5.0. They were designed to extend Java's type system to allow, this is important sentence, to allow a type or a method to operate on an object of various types while providing compile time safety. And this is the key word, compile time safety. Why do we say that? So generics were introduced in Java programming language to provide tighter type checks at compile time. Because usually if you are doing type checking or any kind of checking at runtime, it's always harder to handle, right? So if we manage to find something that we can find errors if they occur at compile time, then this is great, right? So in a nutshell, why do we use them? Generics enable types, whether it's classes or interfaces, to be parameters when defining classes, interfaces, or a method. So it's much like the more familiar formal parameter used in method declarations. type parameters provide a way for you to reuse the same code. Remember when we added 2 integers, then 2 doubles, and we created duplicate codes? Pretty much the same except for the type. Now you can reuse the same code with different inputs or different types. So the difference is that the inputs to formal parameters are values, but in here we have types as our inputs. Types, not value. So also another reason is it provides you with the stronger type checks at compile times, as we said. So Java compiler applies strong type checking to generic code and issues errors if the code violates any type safety. Fixing compile error is always easier than fixing a runtime error. So there's another reason, which is the elimination of casts. So the following code snippet without generics requires casting. So you can create a list. Now, when we say a list, it's basically not specified array list. Now, you can have array list of strings. This is what we are doing, array list of strings, of animals, and so on. But if you're doing this kind of list without providing it with any type, then it could have various types. So you can have a string, you can have an int, and you can have anything you want. But when you're using the elements inside, you need to cast them. However, if you want to make it a little bit tighter, that is going to be of one specific type, then you can say array list of strings. So anything in this list is going to be a string. Now, there is no need to cast anything if you are using that. Let me show you that in code. So here is a list. This is basically a list. It's not of a specific type. And we added hello, this is a string, and an integer. So if we're using this, if we're printing them, then okay, everything is going to be printed. So let's say run, and let's run this code. So hello and 126, because hello is this one. There is no need to cast because it's just printing. But if you needed to add a value to the element in your list, then you need to know that the element in the position or in the index 1 in the second place in that array list is an int, so you cast it, then you add the element. If you try to add this without casting, it's going to throw you an error. See, that says the operator plus is unified for the type's object, because this is of type object. This is why we needed to cast. And there is no way you can add 3 to an object, right? So you needed to cast. Okay, so some other reasons would be enabling programmers to implement generic algorithms. This allows the same code to be used in collections of different types that are generics, are type safe and easier to read. For example, you can use collections.sort on mylist, and this mylist could be array list of strings, array list of integers, array list of animals, as long as they implement a specific interface, the comparable interface. You have seen that before, but let's see something new. This is the first time you're going to see two types in the diamond bracket or in the diamond operator. So here's an example of the generic Java class, which is used to represent an individual entries, key value mappings. So basically, if you have a class named entry that takes two types, now everything you have in here of key type, and another key type in here. So if you entered integer, then every key type is going to be replaced by integer when this is compiled. Same thing happens to a value type whenever that, whatever that value is. If it's of type string, if it's of type double, and all these things, everything in here is going to be replaced with the new type. Now, that said, the changing of the type is happening at compile time because the compiler needs to check. And another key point that you have to remember, that you cannot give it any primitive type. You cannot give it int, for example. No, you have to give it integer. You cannot give it double. You have to give it double. The wrapper classes, it has to be object, non-primitive type. So here's the example we just had, the key value generic class. And here's how we are going to use it. We are going to create entry of string and a string. It's going to be a grade of the name of the student and the letter grade. And we're going to create mark, which is going to be the name of the student and the integer. And as I said, you cannot use int in here. No, you have to use integer. The wrapper class, the object. Now, when you print them, you can print just grade and entry because you have toString in here. toString is going to allow you to print them and show them the way you want. So we showed them with parentheses, key, and value. Now, you can also use that if you're going to get the .get value, .get key, because .get value, this class name, this object name .get value is going to get you the value in here. You can use it in an if statement to see, for example, if a number is prime and so on. You can use .get key and you can use .get value as long as you implemented them in here to return the right thing. So the diamond operator is basically the two angled brackets. It's a pair of angled brackets containing one of more or more type parameters that are sufficiently close context implies. So basically, when you create them, when you create the object grade, you must have the types in here. You must have them. But you can have them in here or you can abandon them in here. So the type of your object must have them because this is the type of the object grade, right? Now you must have them. Now it's optional to have them in creating the object in the heap using the keyword new. So you can abandon them in here. So there is something called type erasure. Type erasure is used to implement generics. So basically it replaces all type parameters in generic types with their bounds or object if the type parameter is unbounded. So if there is a type, it's going to replace it with its bound, okay. But if there is no specific type, it's going to be replacing that with object. Because you know, object is the parent of all classes in the whole world. Okay, the produced bytecode, therefore, contains only ordinary classes, interfaces, and methods, as I said before. So it's not going to be a bytecode of a generic class. No, it's going to be a bytecode of the compiled class, the one that received the type. So how it works, the type erasure, it inserts typecasts if necessary to preserve type safety, because remember, it's all about type safety. It generates bridge methods to preserve polymorphism in extended generic types if there is a polymorphism. Type erasure ensures that no new classes are created for parameterized types. Consequently, generics incur no runtime overhead, which is what we are trying to do in the first place. Compile time things. Do not do runtime overheads, right? Okay. Now, this statement, what does that mean? If there is a type bounded, then it replaces that with a type. If there is no type bounded or it's unbounded, then it replaces that with object. So let's say we have this class. It's called node, and node receives type T. Basically, it's a generic type, right? It's going to be replaced with what's needed. So because of the type parameter is T, and the T is unbounded, and we are going to see what bounded is in the next slide, but because it's unbounded, it does not mean anything to me. It's just the letter T. What is T? So the Java compiler replaces that at a compile time with object. So every T is going to be replaced with object. And node is going to be made general. It's object, right? T object. Node T is just going to remove that and keep just the node, because node is going to be of objects. And here it is again, so T and object. Let's see what is bounded. So in the following example, a generic node class used a bounded type. Bounded means in the brackets, in the angle brackets, I have T, but T means something. T is a child of comparable T. So basically, every T is going to be replaced with comparable. Because as I said, it's a child of comparable. Or you can say that T is a comparable type. So is a, the extends, the inheritance, means that you can replace each T with comparable. This is some kind of polymorphism, right? Okay, with interfaces, you can also have generic interfaces. Like, we had one before when we created our comparable, remember? And you can have public interface, for example, stack interface that takes item. Now, item could be integer, could be string, could be anything. And if we are going to use this in our class, we are going to implement this interface. Then we say, okay, stack item implements stack interface item. So we say, okay, this item is basically that item. Okay, so this is pretty much it for generics. In summary, generics enable types, whether it's classes or interfaces, to be parameters when defining classes, interfaces, or methods. This provides strong type checks at compile time, and this is critical thing to us. Elimination of casts, and by using generics, programmers can implement generic algorithms that work on collections of different types, like when you created or when you used sort collections.sort. You can give it any kind of array list of integers, array list of strings, or anything. Now here's an example. The example will ask you to write a generic method to count the number of elements in a collection that have a specific property. For example, odd integers, prime numbers, palindromes, and all these things. So we have this functional interface. This is a functional interface. A functional interface is an interface with one function inside. So we have this, and we have a class called algorithm. This is the one that will be testing or having our testing algorithm. So public static count if we're going to give it collection T C. So that collection could be arrays, could be array lists or list or anything that it basically eventually is a collection. And we are going to use the unary predicate T. This is the unary predicate T, our function interface. And we are going to use, as you see, we are going to, next step is to implement this test. But first, we are going to use test for every element in that collection. For every element in that collection, use test if the test evaluates to true, and whether we want to test if it's integer, if it's odd, even, palindromes, and all these things, right? So count plus plus and return the count eventually. So basically, we have to implement our test function, right? Our test function. So what we are doing is test returns whether it's basically what we are doing here, if it's odd. If it's odd. Now, let's take this one and try it. So when we try it in the main, we are going to do, okay, collections integer, ci, arrays dot as list. We are going to take this as list. So this is my list. And list is a collection, so I can use it in there. So I give ci, which is a collection of integers, and I use the new odd predicate, which is basically this one that uses the test. Remember, you're using test in here. You're using p.test. So int count equal algorithm.count if ci, and this is going to say, okay, what kind of actions that you're going to do. You're creating object of this one, and the object has access to the test. And number of odd integers count. So basically that is going to come in here and says, okay, I'm going to start counting. Start counting it from 0. For every element in this array list. So, sorry. Check test this element, and the test is going to be the following. Is it divisible by 2 and the remainder is 0 or not? So I mod 2 not equals 0, so the remainder is not 0, which means it's not even, right? So if yes, then count plus plus. Okay, let's try this code. Let me just copy these things. Just get rid of the whole thing in here. Then copy the next part. Format the whole thing. And this needs to import collections because we need it in here. And this one needs arrays. We can do it in here. And okay, first let me just run it from here because it's another class name. So the number of odd integers is 2. So let's add 5, 6. Now it's going to be 3. 1, 3, and 5. So a 3, right? We have 3. So now my exercise to you, what I need you to do is, in the previous example, you changed this line. And I want you first to use anonymous class and use lambda expression. So pause the video, and try to do that on your own and come back to see the solution. Okay, so assuming you came back to see the solution, let's do that together. So this is what we are changing, right? So I'm going to say, first we are going to use anonymous classes, right? We are going to use anonymous classes. So anonymous classes, we are going to use this, right? Assuming that this is what we are going to comment, whether you comment it or not, doesn't matter. So you're going to use new unary predicate, and then we open this. Now this is an anonymous class. What's missing is that you need to implement this function, right? You need to implement this function. Now, what that says is that, wait a second. Basically, do we miss any thing? CI new unit predicate integer, we give it an integer, and we say, oh, we missed those two. Okay, now we have an anonymous class. Anonymous class, we are using the functional interface, and we have two parentheses because this is pretty much as an object, using that anonymous class as an object, right? So public boolean test integer I. Let's try this. Now we got our 2. Now let's remove those 2 just to make sure that we will get 2 instead of 3. Okay, that works. That works fine. Now the second requirement was, okay, now create a lambda expression. Now create a lambda expression. So I'm going to create a lambda expression. Now you can do it in here, or you can do it in here. So I'm going to create a lambda expression. Having this, right? Having this in here, and I'm going to kind of name it lamb, whatever. Okay, lamb. Then I'm going to say integer I, and this integer I is going to be doing return whether this I mod 2 not equal 0. Right? And you need now for this one, I need to kind of get rid of the whole thing in here, and I'm just giving that lamb. Now let's see if that works. Yes, that works. Let's add another like 3 and 4 and 5, 7, 9. So let's see if that counts right. Yes, that does. So this is how we do lambda expressions, and how we use them. So you can get to the solution in here and see how we use anonymous class. The way I did it is I didn't create anonymous class object. I didn't store my anonymous class in an object. So I just did that directly and used it in here, right? In here. I put everything in here, the whole thing in here. You could have put it in this place, right? Without creating an extra variable and all these things. Okay, here is how I did the lambda expression too, and I used it in here. Okay, that's it for today. Have a good day and see you in the next video.